Hello friend, welcome to our channel Electrical and Electronic Project. Today we are discussing about the Astable Multivibrator and its use in LED string light making. Friends, as we all know about LED string light, which is used in decorating purpose like in festival, Christmas, Diwali, etc. Friends, you observe that LED string light are blinking. This blinking of light is happen due to a circuit which is known as a stable multivibrator, and this blinking of light are happen due to continuous on and off of the LED. This on and off position are achieved by a stable multivibrator. Friends, as the name a stable multivibrator, the output of this circuit is not stable, means its value is high and low continuously in time interval. So now start the topic. First take a look of a stable multivibrator circuit. This is a stable multivibrator circuit. Here T1 and T2 are identical transistor. This is a group of LED lights. This is a identical capacitor to capacitor C1 and C2. This is a identical resistor R1 and R2. Supply voltage is fed from it. Our rectifier circuit, 6 volt DC rectifier circuit. From this 6 volt DC rectifier circuit, whole circuit are operated. So let's look in the circuit. First look the function of the transistor. So we draw a transistor. We take a black marker. Friends, this is a transistor circuit, transistor symbol. This is base, this is emitter, and this is collector. When base voltage is high, say it 1, when base voltage is high or say it 1, then our transistor goes to saturation region, means short circuit region. It is also known as short circuit region or saturation region. In saturation region, it complete a path like this. Current flow from C to E. When base voltage is 0 or say very low, then our transistor is act as open circuit. So C and E is now act as open circuited. When voltage is base voltage is high, C or E act as a short circuit. So and for capacitor, and here capacitor is also connected. In capacitor, when DC voltage is supplied across it, initially it act as a short circuit. Its short circuit period is T. T time period is equal to R equivalent or C equivalent. Capacitor in the circuit and equivalent resistor in the circuit. It time depend on the RC, means time constant. It is also known as time constant. After time constant, capacitor is fully charged and it acts as an open circuit, and voltage across it is high. High or say is equal to supply voltage. Voltage across it is supply voltage. So basically these two fundamentals are work in this circuit. So take a look in the astable multivibrator circuit. When 6 volt is supplied to the stable multivibrator circuit. In a stable multivibrator circuit, at one time only one transistor is on, and at the same time one transistor is off. We take a assumption that initially T1 is on. When T1 is on, whole current flow from 6 volt here to here and here, because it is on. All current flow from this act as a short circuit, and current flow from this terminal and take a closed path circuit. When circuit is complete, then this LED will glow. This LED will glow. At the same time, this parallel circuit also complete a closed path. We know that initially capacitor act as a short circuit. It act as a short circuit, so their voltage across it is zero. When it is short circuit, then there is no voltage. There is voltage across it is zero. This zero voltage it go to the base of the transistor T2. When base voltage is zero, it act as a open circuited. So no current flow from this LED, or no current flow from this path. Obvious, this no current flow from this, because this path is complete only when it is short circuited. At the after time constant and after some time, when this capacitor is charged, because current flow from here initially it act as a short circuit, after some time capacitor C1 is charged and voltage across it is maximum, say 1. Instead of 0, now voltage is 1, or say high. When high voltage across it, when high voltage across it, then this high voltage is go to the base terminal of the transistor T2. When base is high, say 1, then this transistor act as a saturation region, and this act as a saturation region. So this complete a closed path. Complete a closed path. At the same time, current also flow from here to here, because initially capacitor act as a short circuit. It is short circuited, so voltage here is 0. This 0 voltage go to the transistor T1. So transistor T1 now cut off. Now go to the cut off region, and this LED will not glow because this circuit is open, and now this circuit is closed. Transistor T2 is on position, then this LED will glow. At the same time, current flow from R2 capacitor C2, because initially it is a short circuit. It complete a capacitor C2 also complete a closed path. After time constant, this capacitor also charging. When this capacitor is charging, here voltage instead of 0 goes to high value, say 1. We say 1. And at the same time, when this capacitor is charging, at the same time, because this section is open circuited, this capacitor work as a closed circuit here, and this capacitor, this charging voltage is now discharging through resistor R1. When this is discharging, at the same time this capacitor is charging. When this is charging and its voltage across capacitor C2 is high, this high voltage is go to the base terminal of the transistor 1. Here high voltage is applied. Now this circuit is closed, or go to saturation region. Now when it go to saturation region, current flow from here and also from here, because this is discharging. This discharging current, because this is discharging, voltage across it is 0, and this 0 is go to the base of this. Friends, when this capacitor is discharging, this transistor is off. When this capacitor is discharging, this transistor is off. When this capacitor is charging, this transistor is on. And when this capacitor is charging, this transistor is on. At the one time, only one capacitor is charged and one capacitor is discharged. Another time, next capacitor is charged and previous capacitor is discharged. So we got a waveform like first for this circuit for this half portion we find at time 0 to 1 it is short circuited, means voltage across it is high, and after 1 to 2 it is 0, and after time t2 it again operate, and after t2 to t3 we say time period 1. We also say that t is equal to rc is equal to 1. This is 3. So it is continuously like this for this half circuit also, but at time 0 to 1, here 0 to 1 it is operated and position is in 1. Here at 0 to 1 position is in 0, and 1 to 2 here it is off position, 1 to 2 here it is on position, and so on. So this is a waveform. So there is no stable state uh, at a time interval it is on, but next time interval it is off. 0 to 1 there is no stable state is taken from the circuit. So this circuit is known as a stable multivibrator. Here no stable position are obtained. This application is used in